Greetings and welcome to the 45th of our Town Hall Conversation series. Very exciting to be here today and to share with you a new resource that we believe will be a real game changer for the future of medicine. It's also a really wonderful example of what can be accomplished with philanthropy, with an independent academic medical center and those contributions. So we're going to take a deep dive today into the Bookout Center for Medical Innovation, Technology, Research, and Education. This new center was established by Ann and John F. Bookout. I believe they're Bookout III. I believe they're joining us today online. And it builds on a foundation that was set by John's father, Mr. John F. Bookout, still an active member of the Houston Methodist Board of Directors at the young age of 101. And I can't help but think also today, as we approach the 80th anniversary of D-Day, his generation, and particularly Mr. Bookout, as a veteran, everything that he contributed. So if he's listening, or certainly John, if you could share with him, deep thanks from all of us for his service. Mr. Bookout, the 101-year-old Mr. Bookout, helped create MITEI, the Houston Methodist Institute for Technology, Innovation, and Education, which now becomes part of this overall Bookout Center. This brings together the latest in robotics, imaging, and digital surgery, and will allow us to expand and enhance the training of surgeons here and really all over the world. So today, to talk about the capabilities of that, we're joined by its medical director, Dr. Alan Lumsden, and the director of innovation engineering, Dr. Stuart Core. As always, we invite you to participate in our conversation. You can text your questions right there. If you first text the word DeBakey to 37607, or you can enter your questions in the live stream chat box, and they'll be answered there by Dr. Chris Ibarra, who is the Director of DeBakey Cardiovascular Education. And thank you, Dr. Ibarra, for being here today to answer those questions directly. So I'm going to start with Dr. Lumsden. Please tell us what we're accomplishing to date in this wonderful center.
Well, thank you, Dr. Boom. It's a pleasure to be here. If I may, let me start off by thanking the Bookout family. I have many reasons to thank multiple generations. Mr. John F. Bookout, I consider as one of the architects of Methodist as it currently exists, and he and Ron Gerardo took a chance on me and gave me this job that I've been very proud to serve in. And then secondly, to thank John and Ann Bookout for being visionary and helping to create this Bookout Center and being very active participants in it. I think it's something that we value enormously. So one of the things that we've struggled a little bit with is thinking how to message what it is that we think can be fundamentally different. So let me walk you through this. Part of this is called the Methodist Institute for Robotics, Imaging, and Navigation. We used that title several years ago as we started the idea of how do we put this together. So why do these components come together, and how does MITEI function as the center of this? On the top left-hand corner there is a CAT scan. CAT scans are ubiquitous. You can get them all over the place. And if you drop down below that, you can see how we typically think of a CAT scan. A CAT scan is usually slices which are made and radiologists which interpret them. We got a little more sophisticated in that we could reconstruct this in that center panel into what we call coronal, which is longitudinal slices, sagittal, where we kind of slice you like from top to bottom, and the axial segment that you look at here. But all of your data is there. You are on this. I think of it as your universe. And so you are on that. And if I show you, what that can look like, then, if we change the way that we window this and look at it, it's like looking at a picture. We can look at your surface. We can look at your blood vessels. We can look at all the structures that are inside. So think about that. This is really how these CAT scans work. What started off as being one slice now has very rapid spiral CAT scans, and so you are in and out of these things amazingly rapidly. You can take a picture of almost your entire body in about 20 seconds, and then it allows us to reconstruct it to look three-dimensionally. Now what we got to do is to take that three-dimensional picture of you or a lung nodule that was taken in one of our outpatient centers and move it into our interventional suites, our operating room, and that's called fusion. And the way that we do this is kind of show you on that left side. Let me just go back one time and show you that again. And so what happens is that as you do this, you can take, for example, a three-dimensional structure that looks like bones. And these bones we can see on the previous CAT scan, and we can actually import that and fuse these things on top of the patient. This is actually a glass model. Imagine this is a CAT scanner, which you can actually see in the background. And on top of that is a robotic catheter. So the idea is the CAT scan your blood vessels in this particular situation. It looks like a road map, like you're driving around Houston. And it's defined by GPS coordinates. It's the same concept here. And if we can now input a robotic catheter into that and control that robot, these robots, and give them a target, these robots, just like a car, can start moving autonomously inside patients' blood vessels or inside an organ cavity. And this was published, actually. This was the first time this had ever been done. This was done here up in Miami, and you can see this was a publication that we did in the Journal of Vascular Surgery. But it's really all about working through long, thin tubes. That's a word that I kind of borrowed from the oil and gas business. One of my partners with Pumps and Pipes, Bill Klein, used to say, we work through long, thin tubes. So many of these technologies can be removed or taken or borrowed from other industries. And what happened with that robotic catheter that moved through blood vessels is that this was taken, the company was bought by a company called Auris, and they converted it into an endobronchial navigation system, working through long, thin tubes. And this is an example now basically of how this can work. You can turn that volume down, but this is a catheter in which is controlled remotely. You take a CAT scan that shows a lung nodule. You determine how you're going to get to that particular location, way out in the lung, and the surgeon can stick a needle in and take a biopsy. This is an example of taking a CAT scan, the imaging, it's digital, fusing it on top of the patient, and then using a robot to follow a predetermined path to take a biopsy. That's really one of the things that we're trying to do here in the Bookout Center. Now again, why have I got a Tesla up here? What a Tesla sees is multiple sensors. It has local radar, it has ultrasound, it has video, but all of it is converted into data. It's the data that is used to control a robotic car. Now we have similar cameras, for example, in our robots in the operating room, and you can see a picture in the bottom right, the one that's activated at the moment, are computer vision cameras in our operating room. We could control robots moving around inside the operating room. For example, could we have a self-assembling operating room? Could all of the parts be robotic? They move out, another robot comes in and sterilizes the operating room, and these cameras are used to control motion paths when we come back into the operating room. Or in the bottom right, this is actually a picture that's taken through a surgical robot by which we can see inside the chest and we can see these different structures. So that's a little bit about the background. I'm going to hand that off to Stuart because we have tremendous robotic capability here at Methodist Hospital. We have some of the leading experts in the United States in GYN, thoracic surgery, general surgery, liver transplant, kidney transplant. And what we're trying, and we have tremendous technology. What we're trying to do with this is be on the forefront of merging imaging into this. That also equals potentially some autonomous movement of these different kinds of robots. And although the physicians can say, here's the idea, the way this is created is by computational scientists and engineers, who can help make this a reality. So with that, I'm going to hand you off to the engineer who helped kind of develop this, and that is Dr. Stuart Core.
Thank you, Dr. Lumsden. So I'm just going to kind of go over kind of activities over the last 4 years here, and to reiterate what Dr. Lumsden has been saying, Houston Methodist has pretty much every single robotic and imaging system available. And as you're seeing on your screen here, there's multiple specialities in that field. So we have cardiovascular, gynecology, urology, neurosurgery, and each speciality has its accompanying robotic and imaging platforms. So one of the first goals is to start unifying and bringing all these key stakeholders together. Bring the surgeons together, bring the staff together, bring the researchers together, start understanding the bottlenecks in their field. And moving on from that, and we want to put a little bit of a system approach to this, and looking around the landscape, looking around the world, there's a place in London, Imperial College London, called the Hamlin Centre for Robotic Surgery. And we really kind of use that as a model to kind of base our next steps forward. And we had the privilege to go over there a year ago and visit Ferdinando, who's the co-director of the centre, and actually went to the House of Lords, which was an interesting experience. But we really got a taste of what they're looking at, and one of the goals was to try and form some sort of partnership with them, collaborative engagement. So concept of Mirren was born, we established it, we looked at key areas of research, which was image-guided robotics, extended reality spatial computing, artificial intelligence, digital surgery, and training and education. Now, critical to this is the ability to publicly disseminate everything we're doing here. So get it out in the public, build that brand awareness, build the recognition of this place as an international recognized hub. And using the full power of the studios that we have here as part of the DeBakey CV education program, we launched our first ever virtual symposium. So back in 2021, I believe, was the first one. I had one in 2022 and 2023. And there's a little QR code there. If you want to scan that or go back to this video and load it up, it will be in the description. That would take you to our last symposium. And it's a really nice merging of industry and academic. So it's a kind of taste of what's happening out there, both externally to Houston Methodist and internally. Now, I actually want Dr. Lumsden to comment on this brand new vascular robotics program which we have launched. Dr. Lumsden?
Oh, thank you. So, in the background, this is Dr. Shara Bavari, one of my partners, and in the background is the Intuitive Surgical Robot. Intuitive is a company that really has dominated surgical robotics. It actually started off as an attempt to make a robot for cardiac surgery, and actually one of our faculty, Dr. Randy Wolf, was one of the prime movers in that. Believe it or not, the first cases were being done in Germany, and while he was doing that, a urologist came by and said, well, that looks pretty interesting. I wonder if we could use that for the prostate. So they wheeled it down and they actually started doing prostatic procedures, and that actually transformed the process because that became the example of how to do this. And the majority of prostatectomies are done now with the robot with a variety of different advantages. My specialty is kind of being a little bit behind the 8 ball in terms of doing this, largely because of concerns of bleeding. And so we started this program. It's been done very carefully, and we're now the lead center in the United States, and we're going to start having people coming down here. And the person who's done this really and led this is Dr. Bavari. So kudos to him.
Thank you. And just to go over some of the innovation engineering projects that we've created over the last 4 years. You may have heard of a thing called the Mightyverse, which is a metaverse for medical innovation, which we pioneered here at Houston Methodist. I'm going to touch on that later. But we're also looking at, how do we interact with robotic systems? How do we take away the physical control systems and control these robots in a very safe manner, allowing for even more enhanced accuracy and precision? And also, how do we simulate surgical procedures? Again, it all ties into this underlying emerging technology, which has this umbrella term of digital surgery. Now, you may have heard of virtual reality and to some extent augmented reality and mixed reality. And if you want to get a primer, there's a little bit of explanation here, but ultimately augmented reality is when you would use a headset and you see things around you. Okay? Mixed reality is you're able to interact with those things that you're seeing. But virtual reality is you're completely in an immersive environment. You could be on Mars, you could be in an operating room, you could be in an outpatient center, you could be literally anywhere. And we kind of bundled up all this work in extended reality and spatial computing into the Mightyverse, and we're going to show you a great promo video that the video production team here put together.
At Houston Methodist, we are creating new realities for our patients, staff, and the global health community. Viewing the whole patient at a time. Exploring the heart from the inside out. Hands-on practice when you need it the most. Remote assistance for times of urgency. And if we are limited by our reality, we create a new one. Welcome to the Mightyverse.
So that's the concept of the Mightyverse, and our flagship product is actually an app that you can download and use in the MetaQuest headset. And I'm going to give you a little peek of what the user would see when they're in this environment. And this is their DeBakey Heart and Vascular Center room. So you're in the room, you're at this podium here, you're able to select content. Now, all of the cardiovascular procedures we perform are recorded, and in some cases we narrate and we edit and trim them up and put them on our YouTube channel. So you're able to watch a procedure in this environment. You're also able to interact with the surgical care team or your collaborators, and you see them joining us here. So these people are patching in to the Mightyverse from different time zones across the world, Europe, UK, different time zones in America. And you see they're going back to the podium. We're going to select an aneurysm repair, and that model, that 3D model, is going to appear. And again, I just need to highlight, this is that patient's heart. It's not a conceptual heart. We took the MRI data, we rendered, segmented, colorized, texturized, so that you're able to hold the patient anatomy in your hand. And you can see here the extent of the aneurysm. So again, you're in this environment, you can engage with collaborators, with the surgical care team, you can look at the patient's anatomy in a way never before possible. You can watch that operation. And you actually see in the background, you can see the Bookout Center, the Research Institute in the background there. Now another experience, this is actually on the new Apple Vision Pro system that just came out. And it's really exciting that Apple have entered the scene now. It helps drive competition, etc. But this footage was taken on the 14th floor of Smith. You can see a fully rendered animation of a patient's heart there. So again, my colleague who's manipulating that image is Austin Shelton, who we just hired earlier this year. He is our XR expert. And this is what he's seeing. He's seeing this beaten heart. He's able to fully rotate. And you'll see in a second, he's going to see that the flow going through that heart.
Can I add a comment, Stuart? So this is all driven by imaging. In this case, it's dynamic imaging. Again, the heart is one of those very dynamic structures, and you really need to see it moving to understand if the valves are not working, for example. And so the same CAT scan can be used for diagnostic purposes, can be used in a VR environment for planning purposes, and then can be used to program a robot of how it was going to interact with these structures.
So we're very excited to see where the Apple headset is going to take us, and we're actively programming and building apps in that. And just another example in the orthopedic space, this is by a company called Also VR, I believe, and they do a lot of total hip, total knee replacement simulations. So again, in the same environment, 14th floor of Smith, Austin's in the Apple headset. Okay, so he's selecting, he's able to simulate range of movement. And he, just to add, he's not using a controller for this. The way the Apple headset works, it's you control it via eye movement and your hands. There's completely no controller at all. Now finally, one of the other projects was, I'm referring to an endovascular robot here called the CorPath GRX. And the important thing about this is that the operator, the surgeon, is able to drive and control the robot from a distance. They're still connected to the robot system by a long wire, but being able to do this from a distance, they're reducing X-ray exposure. So we thought, well, hang on, why do we still need that physical control system? Can we do this in a fully augmented reality environment? And I'm going to show you a demo of this here. So we have Dr. Lumsden. He's wearing a Microsoft HoloLens. The robotic phantom system is in the back, and he's clearly interacting with something with his hands, but it looks like he's just interacting with the air. Now if you give it a second, you're going to see what Dr. Lumsden's seeing, and this is it. He is seeing a fully rendered, augmented version of that control system. To him, he's reaching out with his hands, he's steering, he's guiding the catheter and guide wire. He's able to see the live stream, the live view, and all that information is being transmitted to these robotic arms that we've retrofitted to the robotic control system. So it's essentially a robot controlling a robot in this case, but being controlled ultimately by Dr. Lumsden. And again, the uniqueness of being in Houston is we were able to team up with a company that does work for NASA on the International Space Station, and they were able to help implement this solution, and we could test it at Mighty. So we had all this interaction, all these projects. Then the Bookout Center was directly born from that. So I'm going to give you a little bit of a flavor of where we're going with the Bookout Center, what our mission and vision is. So there's a lot of text here. I'm not going to read it verbatim. But we want the Buchholz Center to be an internationally recognized hub for excellence in medical robotics and imaging technologies that lead towards precise, efficient, and personalized patient care with improved outcomes. That is our vision statement. Now, for a mission statement, we want to create and integrate these new emerging robotic and imaging technologies. And what I really mean by that is create technologies we are looking at current clinical needs and unmet clinical needs and creating the blueprint and even a working prototype in some cases of a solution to that. The integration of this technology is when we're working with industry, where we're pulling in technology that's been developed externally, and we're helping them find a landing point at Houston Methodist, making sure that it's aligned with what we're trying to get, and solving our solutions to our unmet and current clinical needs. And our goals are, all our research, innovation, and education activities, both in conjunction with academia and industry, we want to be highly translational. This is a very, very translational environment. But we're not engineers solving engineering problems, we are engineers solving clinical problems. And there's two key components of the Buchholz Center. It's the 25,000 square foot surgical simulation center, which you know as MIGHTY. So that is contained as a functional component of the Buchholz Center. Then we have this new thing we're calling the IERC. It's the Innovation, Engineering and Research Core. So this is a really unique thing that I believe no one in the Texas Medical Center currently has. And this is a dynamic interdisciplinary team that's specifically focused on solving these unmet clinical needs. So we create technology, we develop, we test, we validate as well. There's a lot of companies out there looking to develop the next cutting edge technology. We can validate that very quickly. And this is just a little bit of our organization chart. We have obviously MIGHTY Innovation Engineering. We have a research department, and then we have administration. And we're renovating. We have about 1,200 square foot at MIGHTY that we're renovating specifically for our innovation and research activities. And we've got a wonderful fly-through here of that space, which I'm going to play. So this is right in the heart of MIGHTY, right in the heart of MIGHTY at the Buchholz Center. We have workstations where people come and work. We then have an open plan development area where we can showcase prototypes, work on larger systems like robotic systems, etc., or extended reality work. Kind of small electronics prototyping area, for 3D printing, etc. And then we have a chemistry area where we can do soft chemistry. Don't really do any biological work here. If we want to do biological work, we'll use the cell hoods upstairs, etc. But think of this as a engineering facility where we're creating prototypes, creating technologies, validating technologies. And just to go back a slide, the way we actually handle new projects, we've kind of borrowed from the biodesign approach, which is a systematic method for finding needs, for screening, for developing concepts, for selecting those concepts, then introduction of development strategy and planning, and then integration. And we're not following the biodesign approach verbatim. We're taking what works for us and we're adding additional factors that will enhance and allow for synergy to take place. And just got a couple of static screenshots there of this new facility at MIGHTY.
Can I make a comment there, Stuart?
Yep.
Again, this is going to be a great facility on its own merit. But we interviewed an engineer yesterday that we're trying to attract to help lead this. The fact that that is embedded inside MIGHTY, where all that imaging equipment exists and some of these robots exist, and immediately adjacent to a hospital where they have access to all of these experts, is a fundamental game changer, what gets people all excited about it. And so it's, the entire total of the ecosystem that's being created here at Methodist is very exciting and very attractive.
And so near-term objectives, what are we trying to look at accomplishing in the next kind of 3 to 6 months, Q3, Q4. We've put together a really rigorous steering committee, which is representative of all the centers of excellence here at Houston Methodist, as well as multiple departments. So we're going to have we're finalizing, going to have our first meeting for that in June, July. Secondly is getting the word out, so building up our reputation, building up our public dissemination activities. So we have our YouTube Bookout Center. I believe Mr. Bookout was the first subscriber to that. So if you want to go on YouTube and just go to Bookout Center, you will be taken to that, and there's already content which we've kind of pulled from the last 4 years. We have our inaugural Bookout Center Symposium, which is scheduled for this year, October 7th to 9th, and we will be sending information out on that. And more importantly, we want to really get a quarterly newsletter out there to our memberships, to our people that are interested, our community. We plan to go live with that on July 1st. So please stay tuned. And again, short-term focus and strategy development. The whole industry and research landscape for robotics and imaging has really changed over the last 5 years. In regards to robotics and industry, it's no longer intuitive. There's a lot of other companies, both big and large, that are getting into that space. There's a little snapshot here. You have CMR Surgical, Zimmer Biomet, Stryker, MMI, which is Medical Microinstruments, a company in Italy. And then from the more research side, you have the likes of Hamlin Center, Georgia Tech, Johns Hopkins, etc. So we've already started establishing really nice connections with those centers and looking at means to collaborate. And this is a little snapshot of our kind of milestones. I believe we have 20 milestones over the next 5 years. So we want to adhere to them as much as we can. And finally, this is a little snapshot of our team, who you'll be working with or who you'll be seeing if we go for tour. And you know, we want to book out the Bookout Center. And I believe that's it, and happy to take any questions.
Well, fantastic. Thank you to both of you. Fascinating. It's just so fun to see both the current but also the potential in the future. We got one question that's probably a good starting question that came over online, which is, okay, parse out a little bit for me, Alan, and this question of how much of this is in current use that you're talking about, how much of this is really about future use?
So robots are very widely used in a variety of different specialties at the moment. And so on any given day, there are bowel resections being done with the robot, there's prostatectomies being done with the robot, hysterectomies being done with the robot, lungs being removed with the robot. And so the platform is established. How you move that into the future, and one of the interesting things about the robot is that every movement of that robot is measured. So one of the things we've really struggled with in surgery, for example, is how do we tell a good surgeon? You know, you have to get somebody who's going to stand there and watch and say, yeah, pretty good surgeon. Measuring it has been a real challenge. Every movement is measured when you've got a robot. And so I think that will help a lot in training. There may be ways that we can impart expert activity into a novice in terms of how they use that robot. Then ultimately what we're particularly interested, so for example, if you wanted to remove a tumor in the middle of the liver, well, as a surgeon you see the surface of the liver, but what we really want to see is the blood vessels and the bile ducts and all of that kind of stuff inside the liver. And so that's called soft tissue fusion and deformation. Unfortunately, when you put the robot and you change the pressure in the abdomen, the liver deforms. So the whole industry is being developed in terms of how do you model changes. When you look at the brain and you take the skull off, there's some distortion of the brain. And when you start taking parts of a tumor out, it distorts movement, it distorts more. And so how do you continually update the images so that you can control the robot? That's kind of the futuristic stuff, but well within our capability of getting to that. So the answer to that is some of it's being done routinely, some of it is, you know, futuristic stuff that we're working on.
So embedded in that question was a question about how much of this is being used in training. You touched on that a little bit, certainly in assessment, but this has got to change the training paradigm for people in procedural specialties.
Absolutely. And so in the past, the pathway was you, as a general surgeon, you learn to do laparoscopic surgery. Now think about it. There's a reason that Intuitive Surgical uses the name Intuitive. In the past, you can use this as an example of a scope put inside somebody's abdomen. If I wanted to move the scope to the patient's left, I had to move my hand in exactly the opposite direction.
Because you're operating through a tube.
Because you're operating through a tube. So the surface of the skin and the tube moves like that. What Intuitive did was they got rid of this reversed movement, and instead they built a wrist that really mimics the wrist of the physician. And so many training programs now are bypassing laparoscopic surgery. There's discussion whether that's a good thing and going straight to the robot. But relearning to do laparoscopic surgery would be a challenge. The wrist, interestingly enough, was built by a Rice aerospace engineer who went to NASA. He's a runner. Now, his name's Dan Wallace. He found it to be too hot, so he moved to San Francisco. And he was one of the founders, along with a guy called Fred Moll, who built Intuitive Surgical. They're also the ones who built that snake robot, and so that moves inside blood vessels. So it's the same people, innovate around this space again and again and again.
But so with a lab like Mighty, with a lot of this work being done, I mean, I think back to when I was in medical school, really kind of a little before the birth of some of the laparoscopic things even that were happening. If you wanted to learn surgery, you had to do it on somebody, right? Mm-hmm. So now how do you take a new graduated resident or medical student who then graduates, becomes a physician, now they're going through training. How much are they doing in a place like this before they ever even do anything on a human being? How do you do those work with that training?
So multiple different approaches to doing this. I mean, Stuart showed you that you can take things, put them in a VR or in a simulator and make them look real. So a lot of simulation occurs around robotics. You can put a trainee in a robotic system and give them a series of tasks. It doesn't really look like a patient, but the tasks are very specifically designed to mimic some of the movements inside the patient. Then you can scale it up to being more patient-like, but it's still kind of cartoonish. I mean, the opportunity is to kind of do the Tesla thing and make this look exactly like the inside of an abdomen. And this is where video capture, so for example, a conversation that we had this morning is we record a lot of stuff, both intraoperatively and around the hospital. That's valuable. Okay? And the question is, how long are we going to keep this? I'm almost afraid to delete something because down the line, the Tesla training, for example, not only did Elon Musk record what the car saw, but he was recording how you responded to it. And then you could parse out, here's the scenario, and here's how a good driver responded, an average driver responded, and a driver who you really don't want to be driving. And that is used then to train the AI to run the robot. And so all of this information that we've got, whether it's from inside an operating room or from inside a patient, is incredibly valuable. But man, it's a real big storage problem because it's just enormous amounts of data.
Yeah. Well, great. Well, thank you. I'll come back to some more questions. Corey, we got a question ahead of time about the amazing job opportunities that this obviously presents. It's amazing, interesting field. Talk a little bit about your background, how you got to where you've gotten, and then talk about the team you're building and the kinds of people you've hired and are hiring kind of across this, because it's probably a different cross-section than some of the things we think about traditionally in a hospital systems.
So I guess in brief, when I originally went to undergrad school in University of Glasgow, I studied electronics with music. So I was playing a lot of guitar, writing songs, etc., but I loved electronics. Realised that I didn't want to be a rock and roll star when I got to 2021, but I developed a real keen interest in science and engineering. So I then veered off towards nanotechnology with electronics, etc. Fast forward, I started my American journey in 2006 at Rice, MD Anderson Cancer Center, then Baylor College of Medicine, and we're focused on developing a nano-assisted hypothermia system for cancer. Kind of ended that project and got more into innovation. But during that time I kept my interest in science, so I kind of dabbled in chemistry, got a master's in chemistry, and just learned as much as I could about physics and engineering, bioengineering, etc. And then obviously I'm here now. But for the people I've been hiring along the way, the first thing I look at is, okay, what's your skill set? I don't want to see how well you've done at university, if you got straight A's or not. I'm interested in what can you create, what can you make. So you find a lot of students, they may have done well at university, but they're still not able to code. They're not able to translate all the theory that they've learned into something that can be done. So Austin Shelton's a great example. I mean, he graduated Rice, the Global Medical Innovation Program and Masters, and he's a real self-learner as well, so he's able to take on new projects. And I say, look, I need you to learn Swift so he can develop for the Apple headset. I need you to learn
Swift is a
Swift is the coding language, the operating system for building applications in the Apple headset.
Got it.
And Unity is also another version of that, but more for the Meta Quest systems. So long story short, my advice is pick up coding languages, pick up skill sets where you can rapidly prototype, where you can develop an app for an iPhone or an XR headset. Pick up all these AI applications that are on at the moment. So regenerative AI, so generative AI, there's a method that you can use to code in that. So you basically want to join with all these skill sets, you can rapidly deploy prototypes.
Fantastic. And so as you project out the next couple of years, I mean, how many people are you expecting to hire within Mighty, or within the Bookout Center?
So I don't want to put a number on it at this point. We're growing steadily and surely. The main goal is to develop the team. Right? We have to get the right team there with the right skill sets as well. So we're looking for, ultimately at the moment, a couple of extra hires. Then over the next 3 to 4 years, as we get the business strategy in place, the revenue strategy, etc., we're looking to hire more people. So multiple levels, master's, undergrad, PhD as well. Even those that have done a PhD but don't want to go into academia, they want to go more into industry and actually develop clinical impact products. Those are the type of people we're looking for as well.
Yeah, I mean, if I can add to that is, he's speaking a language that I barely understand, okay? and that's why having a partner, an engineer partner, I think is so fundamentally important, is that it's a different communication style, it's a different language. I go back to pumps and pipes as an example. I'm standing in front of a group of oil and gas engineers. It's very difficult to make sure you communicate what these problems are. So you may look like you actually have an intersection, then you look at it in a different dimension and you completely miss. And I think that there are so many opportunities that are probably lost because of that miss. And so having an engineer who's embedded in a department, who's comfortable coming in an operating room and looking at problems with a completely different light, and then saying, okay, these are the people that we need to try and solve this problem. That's not something the average physician, and an example of that, can do. So you got to basically have partners who can help take that to another level.
So you mentioned YouTube. I know that's been a very successful strategy. We're actually sitting in a studio that you helped create. But within this, I mean, how big an outreach is that, and who's using the things that you develop on there?
So again, it's all about communication. I've always said that we do a remarkably good job at excellence, and Houston Methodist done less good job in beating our chest and showing the world how good we are. We're getting better at it. And so part of the challenge was, how do we get the word out? And there are multiple different vehicles for that, but you know, the highest usage of a search engine is Google. Number 2, YouTube, who actually happens to be owned by Google, so they've really got it all. But the younger generation tends to use YouTube. And so one of the things that our faculty work very hard. We really don't want them to ask them to do more, but they're very enthusiastic about us using what they do. The amount of hours, if you think, that our faculty spend creating PowerPoint presentations, which exist after they've worked on it for 5 hours for 10 minutes and there's gone. The ability to capture that and to produce a product out of that and to make it available. And so, you know, I also think it helps serve underserved communities. I mean, we don't charge for this. You know, anywhere in the world who has, you know, an internet access, get access to our very high quality education products.
So is it mostly people in the field who want to learn about how to do a procedure, or et cetera, or is it oftentimes even educated patients who want to understand what they're about to go through?
Yeah, I mean, you hit it. It's all of the above to some extent, is that every cardiac vascular cardiology trainee in the United States uses our YouTube channel. We were sent a picture of how MGH was using it at their case conferences. And so they use it in a variety of different ways. The products that are up there are cases. That tends to be used by residents and surgeons. There are lectures like our grand rounds. I mean, we invite the top people in the world to come and do that, and we then make that available. So there are a number of different usage factors. Now, do patients use it? Yeah, they do actually. It's, I mean, a number of times I've gone in and said, let me explain to you what the operation is we're going to do tomorrow. And they go, don't worry. Okay, you know what?
I already watched one.
I already watched it.
Yeah.
And so, not everybody wants to watch it.
Not everybody wants to
watch it, but there's an interested group who do watch it.
Mm-hmm. That's great. Well, I want to make sure I cover a couple other questions that had come in. One, I'll open up to both of you, but it was a question specifically around how artificial intelligence is presently being used in patient care, and what are the plans within this center to implement that in the future. I don't know which one of you wants to take that question. Okay, I'm seeing pointing over to Dr. Lumsden there.
You know, as you know, Mark, I mean, this hospital is incredibly progressive. Now, AI means multiple things to multiple different people. So let me give you an example of how we use it. Simple things, and some of these things are introduced not without controversy. I mean, every time you do something new, you know, the medical staff kind of pushes back, and I showed you a clip from cameras in the operating room. They are primarily used for OR efficiency, and so to give you an idea, when a patient rolled in an operating room, I used to get a text message from a nurse to say patient's in the operating room. Then she'd come and say, okay, patient's now ready. That's time, and one of the things that COVID really emphasized to us is the value of a nurse's time. We've really got to get rid of the things that they don't really need to be doing. And so, you know, we have cameras now which will automatically tell us when the patient's in the room. Our drapes are blue, so when they're all blue, patient's ready for surgery, and it tells us when the patient is out of the operating room. And so we just looked at 6,000 events around this, and that is being presented at the European Journal of Vascular Surgery. The nurses were very accurate, but you don't need to do that. And so we want our nurses at the bedside doing things that a bedside nurse needs to have. That's one example, you know, of how this is being utilized. Another example that you're aware of is, you know, for example, we had a blip in cardiac surgery mortality a couple of years ago, and we always assume it's us, and we're looking at things in the hospital. Well, it wasn't until we got different kinds of AI, we looked at it, and with the patients from day 0 to 7, patients in the hospital, we ranked like number 5 in the United States. From day 7 to 14, mortality started dropping. By 21 to 28 days, we're down ranked to number 50. The patient's not even in the hospital at that point in time. And so we suddenly realized we'd been completely focusing on the wrong things, and that now we needed to figure out how to project, you know, our care for the first month, because that's basically what we reported at. And it allowed us, by having, you know, analytics running in the background and then pointing this out to us, to spend the amount of time that we needed on focusing on what needed to be fixed and ignore the things that were largely running pretty well.
So I'm going to take an AI question then all the way, and robotic question all the way out there, and then I'm going to wrap things up. You mentioned, I think at some point you had a robot controlling a robot, or, you know, you were a robot, you were a person controlling a robot who's controlling a robot. When's the person maybe not in that loop as much? Does that happen? Is that conceivable? And I expand that to, you mentioned how we're helping through YouTube, able to help people around the world. For example, there are so many places around the planet, and just go into rural America, where you can't access things, and oftentimes in emergency situations. What are some of the potential for that? So I know it's a broad question.
So let me take that on. And so, you know, this is not today, but you're right. A friend of mine moved 3 hours away from Houston. The speed at which quality care declines, and then take stroke, for example. Stroke is one of the areas that's really being focused on at the moment. When you get a blocked blood vessel in your brain and you're having a stroke, the clock is ticking. You really want to get to a center and get that opened up within a matter of 90 minutes, ideally, to do that. Well, that's fine when you're inside the city of Houston. You've got 3 big centers down here, all of whom can do it, and now increasingly in our peripheral hospitals. But when you go away, that doesn't exist. And strokes don't kill you. They just maim you for the rest of your life. And so that robot that we looked at was bought actually by Siemens, an imaging company. The imaging companies now see the value in having a robot. You could take this image, and the whole idea was, could you build a robot that could be controlled by our interventionists here, who have the expertise, but do it remotely. In other words, you go to the nearest hospital where they got a robot. We'd set up a network of these things. You go upside into the brain, you pull out that blood clot, you reestablish blood supply, and then you figure out where the patient needs to be shipped after you've reestablished that. And so that is one of the things.
So you'd be doing that remotely.
You'd
so
do
you'd
that
need
remotely.
the equipment and some personnel trained enough to insert catheters and things like that for you, and then but the true skill could reside in a central location. You can't possibly disperse that kind of training.
So you can't, because
around every small hospital in every rural area in the United States.
There's not enough people, and there's not enough volume to make it economically viable to train these people and put them across the United States.
Or to have them trained well enough and sitting there with them. So many exciting things, and I think the answer to many solutions. I want to thank both of you for a fascinating presentation. I know there'll probably many more questions, and I heard an offer in there that tours are possible. So we can certainly work with anybody who's watching here. If you work with our foundation team and you'd like a tour at some time, we'd be delighted to organize it. I will tell you, having toured this space many, many times, I haven't seen the new stuff that they're working on. It's really quite fascinating and heartwarming. So I'm going to give you just a quick update on some of the goings on here. I wanted to start with a voice of the nurse. We celebrated Nurses Week now almost a month ago. The week after that was Hospital Employees Week, and we have 32,000 wonderful employees here, and we can't do anything we talk about without all those people and the culture that we so deliberately create. I wanted to read to you a bit of a speech. This individual you see here is Latricia Antia, who was a 2023 Brown Foundation award-winning nurse, who then spoke. This is actually the waterfall, which isn't running right now, over at the Texas Medical Center across the street. In that photo you see of her giving a speech really across the Texas Medical Center. So I'm going to read you just a little bit about her story, because it really underscores the kind of technology we have here, but the heart and soul of the people that work here. When you pair those together, that's really the magic of Houston Methodist. So Latricia goes on to say, I always wanted to be a teacher or possibly in the medical field. And when I was a little girl, my sister and I would line up our Barbies and stuffed animals and pretend they were our students or our patients. But in 1999, when I was a high school student, things got really real. I watched my dad be treated for a rare tumor of the carotid body at Houston Methodist Hospital. During that time, the surgery was unprecedented, it was risky, and it had a very delicate recovery period that was a very critical time. But God sent angels in the form of nurses to care for my dad, and it was the first time I really saw nurses in action. I was in awe of their kindness, their compassion, and their skill. And during that difficult time, I realized I wanted to have the knowledge and skills to help people when they're most vulnerable and put their hearts and minds at ease. She goes on to say, my first nursing job was in a neurosurgery acute care unit, working with patients and families undergoing this very similar circumstances that her family and she had experienced, and goes on further to talk about the value of nursing and the nobility of that profession. So just as we have amazing physician, engineer, scientists, nurses, therapists, you name it here, people who come to work every day thinking, how do they make other people's lives better? So thank you to Latricia and to all of our nurses and all of our employees as well. I love the picture on the bottom. They got a nice everybody jumping picture there as well. I'm going to give you a couple other details. That next week, of course, was Hospital Week. We pull out all the stops and just celebrate. It's a great time to have a lot of fun with people. We always focus on how do you bring people to our institution who derive passion and purpose from what they do, because when you find people like that and provide that passion and purpose that healthcare provides, they go to the ends of the earth to care for others. And so it was a wonderful time to celebrate them. A couple other celebrations going on. Houston Methodist Clear Lake, it's hard to believe it's already been 10 years, but we went out and celebrated our 10-year anniversary of Houston Methodist Clear Lake. And also have done a number of other things in the community. One of the things I'm very proud of, there's an organization in town called Legacy Community Health Services. They are what's called a FQHC, or a federally qualified health center. A federally qualified health center works in an underserved area of town, and once you get them established and moving and they get that designation, they're actually able to draw down specific federal funds to provide care for those otherwise underserved individuals. We've had a long-standing, over a quarter of a century partnership with Legacy. Well, our board decided a couple years ago that we wanted to lean even more into some of the parts of town that were underserved by healthcare. And so we made a $50 million grant to Legacy, the largest in their history, to help them build 2 sites in town. The groundbreaking just happened almost a month ago now in the Pasadena area. There'll be another one, probably groundbreaking sometime in the fall in the Acres Homes area. I'm very proud of our partnership, and this will impact literally thousands and thousands of people. And a great merging of both our institutional support in the community and our community benefits and all of the charity care we provide, as well as the support of those who give philanthropically to Houston Methodist, because we will locate fellows and residents and faculty there to provide additional care, and we do that through a Community Scholars Program that's funded by a number of very generous donors here that support us. Lots of growth going on. This is actually Houston Methodist Cypress, so out 290. We actually officially opened the MOB2, the back one on the back right of that photo. MOB is Medical Office Building on March 18th, and then the front one opened on May 6th. They're not fully open. We're still building out a lot of physician space, but a number of activities are already happening there. And then on the left side, you see the hospital. It's amazing. It's been basically 2 years since we broke ground on this. That's how quickly, with a mostly greenfield site, we could move. That will be turned over to us probably in the November or so timeframe, meaning about 60 to 90 day operationalizing of it. So early 2025, we will be running that hospital fully. One of the really exciting things that's happened here in the research realm, and really in the first-in-man realm, that's something Dr. Lumsden likes to talk, or first-in-human realm that Dr. Lumsden likes to talk about. This is within our J.C. Walter Jr. Transplant Center, and it's focusing on how do you care for patients with liver failure. Now, one of the problems with organ failure and organ transplant is ultimately there's not enough organs to go around, and so ultimately many people pass away, get particularly ill from that chronic liver failure. Well, if you can rethink some ways to do this, perhaps we can make a difference. And of course, engineering organs is something you've heard before on this, around work being done. This is specifically around taking hepatocytes, those are the active cells in the liver basically that do all the work of the liver, and injecting them into some of the lymph nodes within the abdomen, basically creating little micro livers, because the liver is a very regenerative organ. We were the first in humans to do this past couple of months, and very exciting about the promise that's held. This is obviously still in trials at this point. We have a wonderful partnership as an independent academic medical center with several institutions. Obviously, Weill Cornell will actually celebrate our 10-year anniversary of that. Mr. Bookout was instrumental in making that happen, but that started in 2004. So believe it or not, this month in 2004, we first announced that and formalized that in about August of 2004. And of course, we have a great relationship with Rice University in burgeoning. I've shown you some things there. And we have this wonderful relationship, particularly around engineering medicine, or NMed, with Texas A&M. The second class of NMed has now graduated. So we've had 2 classes. These individuals are, they're just amazing. They're all engineering background, computer science background, who come and get a 4-year MD degree as well as a master's in engineering science. And they are going kind of to a who's who, including Houston Methodist, of residency programs around the country. Coming up here on the right, you see Dr. Victor Zhao, who is the second amazing luminary we've had speaking at those graduations, and it's just a great event, and we congratulate each of them. I always talk about focus on the fundamental, and the awards will follow. We've gotten a couple more since last time, listed, actually 3 of our hospitals listed on Best Maternity Hospitals. Really nicely on the bottom right, an organization working with Fortune, coming up with the top 15 health systems. They actually do the top 5 large, top 5 medium, and top 5 small. We're a large health system, and we're in the top 5 in the country based on the data and the processes they do. And then Glassdoor, which is sort of we talked about recruiting and jobs. It's a job recruiting and job rating and other sites. Actually, we were named as one of the country's best led large companies, and that was kind of a nice honor for the leadership team here that works very hard to build and create that culture. And then finally, we never sit still here as we continue to build and continue to recapitalize and grow the main campus. On the left, you see, on the left photo, you'll see Walter Tower, which opened up in 2018. And then abutting that in the rendering, you'll see what Centennial Tower would look at it. Now, if you swivel around, that's looking kind of west, if you look at the left picture. Now, if you look south and you swivel around, you can see Walter Tower in the background. Right behind that would be the Research Institute where MITey is located. But you can see we're already up about 9, 10 floors and adding another floor every 3, 4 weeks. And so this building is moving quickly. We'll be starting to move into it in about 2027 in about 5 stages. So excited about that development as well. And with that, I'll wrap things up today. It's been wonderful seeing everybody. We're going to take a little bit of a break during the summer. We hope you all have a wonderful and particularly safe summer. I want to thank Drs. Lumsden and Corr for being here. Also, Dr. Chris Ibarra, who was there typing and answering questions on the live stream. If you want to learn more about the Bookouts Center, send us an email. The address will be on the screen. You can ask questions about that. And again, if you're interested in some tours or things, we'll be happy to help you with that. We'll be back Thursday, August 15th for a town hall that's going to focus actually entirely on nursing, which I teed up with our letter from our nurse, our speech from our nurse earlier. Have a wonderful summer, and we'll see you in August.